Hi, everyone, and welcome to Multi-Scan Packages, Use Cases and Benefits, a webinar by Headwall Photonics. It is Tuesday, June 4th at 1 p.m. This webinar is being recorded and should be available for viewing within 48 hours. We will answer as many of your questions live as possible. Additional questions can be answered by email. You can send those to marketing@headwallphotonics.com. My name is Marissa DuPont, and I am the marketing specialist here at Headwall. Just a quick overview of our agenda. We'll talk about hyperspectral imaging, the multi-scan packages. We'll talk about a case study on blueberry grading and another on textile sorting, our lab-based solutions, our inline solutions, and summarize and Q&A. Oops. And you can ask questions using the questions panel in your GoToWebinar control panel on your PC or phone. And you can see where to find those on your screen right now. Okay, and now I'd like to turn it over to, actually, let me introduce Mikhael Jobran, Business Development and Sales Manager for Machine Vision in the Americas here at Headwall, Will Rock, Ph.D., Product Manager of Machine Vision at Headwall, and George Killian, our Application Scientist here at Headwall. And now I will turn it over to Mikhael.
Thanks, Marissa, and thanks to you all for attending today's webinar. It's exciting to be able to talk about our multi-scan packages, which is unique and interesting. And before we get into that, I'd like to start by giving a brief introduction into Headwall Photonics. So Headwall Photonics has been in business since 2003. It was acquired by Arsenal Capital Partners in 2022. We're headquartered in Walton, Mass, and we have 2 other facilities in Massachusetts. Our grating and special program manufacturing in Fitchburg, Mass. Our micro replication center, where our sister company Holographics is located, is in Marlborough, Massachusetts. We also have 2 machine vision centers in Delft, Netherlands, and that's where our sister company perClass is located, and Nuremberg, Germany, and that's where InnoSpec is located. We have over 100 highly skilled employees with 40,000 square foot of engineering and manufacturing facilities. Next slide, please. So our group of companies is split into 3 different business units: machine vision, remote sensing, and OEM optical components and assemblies. Our machine vision business unit is mainly working on lab, at-line, and process applications. We are known for having turnkey hyperspectral imaging solutions. You could have 1 or multiple cameras ranging from V-near to near to SWIR, along with a stage, lighting, software, meaning you could start acquiring data from day 1. So if you decide to do business with us, you get your package, you assemble it in 30 to 60 minutes, and you just start acquiring data. Our remote sensing also are known for having turnkey airborne packages. You could visit our website to learn more about them as well. And our OEM optical components and assemblies business unit is known for doing optical components like holographic gratings, spectrographs, and spectrometers. We also encourage you to look at our website and learn more about that. Next slide, please. And now I'd like to pass it on to my colleague, Dr. Will Rock, our product manager for machine vision.
Thank you very much, Mikhael. I'm going to give you a brief introduction to the Headwall group of companies that consists of 4 exciting brands. So the Headwall group of companies can provide solutions all the way from individual optical components that's highlighted by holographics and Headwall. So Headwall is known for its OEM spectrometers and also its holographic gratings. Holographics is known for its expertise in replicated gratings, micro lens arrays, and other microstructures. And the Headwall group of companies also includes everything you need for your hyperspectral solution with software solutions from perClass that has developed great software for machine vision data analysis and deployment. And the newest addition to the Headwall group of companies, InnoSpec, that has brought a great pedigree in machine vision solutions and industrial deployments of hyperspectral imaging. And so when we put all those together, we can offer you great solutions for hyperspectral imaging. So on the next slide, I'm just going to go over our line of sensors. So the MVC V-Near, the MVX V-Near, and the V-Near E-Series all provide hyperspectral imaging in the spectral range of 400 to 1,000 nanometers. The MVC V-Near is the component level machine vision solution. The MVX V-Near has an MVC V-Near inside it and also includes embedded computing and ingress protection. And the V-Near E-Series is the scientific grade V-Near solution from Headwall. The MVC Near is our near solution for machine vision that covers the 900 to 1700 nanometer spectral range. And the SWIR 640 is our MCT array sensor that covers the spectral range from 900 to 2500 nanometers. And in today's webinar, we are highlighting our multi-scan packages, which include the V-Near Near combination and the V-Near SWIR combination. The V-Near Near package includes the MVC V-Near and the MVC Near sensors. And the V-Near SWIR package includes the MVC V-Near and the SWIR sensor as well. And that SWIR sensor can be either the standard SWIR 640 or the SWIR 384, which you can see in the image with me right now. So this is the multi-scan SWIR package with the SWIR 384 and the Headwall MVC V-Near on a perClass scanning stage. And we are currently running a promotion on this very package. And so if you want more information about that, please contact info@headwallphotonics.com if you haven't already seen that promotion come through in your emails. So on the next slide, I'm just going to talk about, again, the packages that we're going to be highlighting in this webinar. Again, of course, the dual scan packages, you can see the SWIR version on the live video next to me. On the slide, you can see the Near version of the dual scan package featuring the MVC Near and the MVC V-Near. These packages provide everything you need to collect, train, and deploy hyperspectral solutions all out of the box. So it will give you everything that you need from the computer, the software, the scanning, the lighting, the lenses to be highly successful in developing hyperspectral imaging solutions. And we know that these packages provide you everything you need to easily set up, operate, and succeed with your hyperspectral solutions. And so please, the next slide, I'm going to give a brief introduction to hyperspectral imaging in general, just to set the stage for what it is and give you a foundation so you can understand some of the cool things that we'll show you that it can do. So what is hyperspectral imaging? It is the combination of imaging and spectroscopy and allows you to leverage all of the advantages of both. So you can use all of the tricks that you can use when analyzing an image by segmenting different parts of the image or by recognizing different parts of the image as containing different heterogeneous features. Or you can leverage the strength of spectroscopy where in a hyperspectral image, every single pixel in the scene has a complete continuous spectrum. So one of the standard ways that we analyze a hyperspectral image stream or data cube is by creating a model that will recognize a library of spectral shapes and assign a class to every pixel in the scene based on its spectral shape. So the image that you see here is an image of 6 different white powders that to the naked eye all look very similar. And so it's really difficult to tell the difference between these white powders by the naked eye. But as you can see from the spectra that are shown with the arrows next to them as well, that the reflectance spectra of these white powders are all quite different. So it's actually very straightforward for a Near or SWIR hyperspectral imager to tell the difference between these 6 different white powders. And so when we build a simple model that just recognizes these 6 different spectral shapes and assigns a false color based on whenever the model encounters that spectral shape, as you can see in this overlay here. So now, like in the upper left is sodium chloride, just table salt. And when we encounter a spectrum that looks like that blue line, we color the pixel blue. And in the upper right is sodium bicarbonate. And so when we encounter a pixel that's very similar to that fairly featureless line, green line to the right of it, we color it green, and so on and so forth for the other pixels in the scene. And this is a very quick and straightforward way to visualize the power of hyperspectral imaging. And through the rest of this webinar, we'll show you some other neat tricks that we can do as spectroscopists with a hyperspectral data stream. So now I'd like to turn the webinar over to our application scientist, George Killian. First, you will see him appear in a short video, and then he will take you home the rest of the way talking about some of these cool applications that utilize the dual scan capabilities of our new packages. Thank you very much.
Hello, my name is George Killian, application scientist here at Headwall Photonics, part of the Headwall group of companies. I will be providing you with an overview of the multi-scan packages we have, why they're so unique, so important, and how to best utilize them. When it comes to hyperspectral imaging, the more spectral data we can collect, the more information we can gather about what we're looking at. However, each spectral range provides different insights. Take fruit, for example. While the visible range might provide information on the color and any defects there, the near-infrared range can provide information on the sweetness, acidity, and firmness of the fruit. If we were in the lab gathering data or at an at-line inspection station, we don't want to lose valuable time changing sensors or scanning the same items on multiple stations. That's where our multi-scan packages come in. With the latest version of perClass Mira and with the Headwall Group family of products, we can collect simultaneously from multiple sensors. I have set up here on the perClass stage an MVC near sensor and an MVC V near sensor via the mounting bracket. Both sensors are controlled by our MVPC running perClass Mira software. To start, I will initialize perClass Mira and connect to the MVC near sensor as normal. I'll follow the protocol of calibrating the instrument by determining the optimum exposure, frame rate, taking a white and dark reference, and connecting to the perClass stage. Once this is complete, I'll then initialize a worker instance of perClass Mira for the MVC V-near sensor. I'll follow the same protocol as earlier, but for this sensor. The name of the image collected and the control for the stage are both done through the master instance of perClass Mira, in this instance via the MVC near sensor. I've also established a separate directory for both sensors to gather the data. Now, with a single button press, I can capture multiple hyperspectral images simultaneously, saving valuable time when either in the lab conducting feasibility studies or at line for quality and safety inspection. Of course, we're not limited to just 2 sensors you see here. This functionality also works with our SWIR sensors, and in addition, we can connect over TCP/IP connection to multiple computers for even more sensors, which is ideal for feasibility studies or quality assessments done inline. Hyperspectral imaging is a powerful tool, but historically it would take considerable time to gather information across all spectral ranges. With Headwall's multi-scan packages, we save time, one of your most valuable assets, and we allow users to quickly assess their product and take advantage of what all hyperspectral imaging can do for you.
So now that we've got a quick video that gives us a quick overlook on what these multi-scan packages to do, I'd like to go into 2 specific feasibility studies for us to be able to go over. But first, just a quick recap of what are some of the challenges with our historical single scan method and what multi-scan packages can do for us. First and foremost, as Will's mentioned before, different spectral ranges provide different chemical information. If we have to be able to rely on the single scan method, we're only getting a little bit of information at a time while we're collecting these images. In fact, many of our traditional hyperspectral lab systems limit collections to just 1 sensor at a time. When we're in the lab and we're looking at a new specimen, the ideal spectral range isn't always known to us in a feasibility study. So in order for us to be able to optimize what we want hyperspectral imaging to do for us, we first need to be able to figure out what that spectral range is. And inline solutions may require multiple spectral ranges to perform different types of actions. So on the next slide, just a quick summary of what we saw in that video is that multi-scan packages are well integrated. They allow us to collect more data for a wide variety of applications, meaning you collect twice the data in half the time. They're not limited to just 2 sensors, so the more sensors you can envision for your particular deployment, we can support. Multi-scan packages can be utilized in the lab, at line, or inline. And the time saved in data collection allows for more time for model development and testing deployment to keep tweaking that model until it's absolutely perfect for your particular application. So we want to be able to capture the full range of spectral information. Let's see exactly one of those case studies. So let's start with blueberries. To start this feasibility study, we want to accomplish two goals. First, we want to be able to identify defects, which can be seen via regions of bruising, and categorize these berries as either good berries or bad berries. We also want to be able to leverage hyperspectral imaging to estimate the Brix value of each berry, which can often be associated with its sweetness. So how we did this is we collected local blueberries, and the berry quality was determined by the grower. The Brix value was determined by a handheld digital refractometer. These images were collected by a Veneer dual acquisition package, the same one that you saw in the video, and the data was analyzed via our perClass Mira software. So if we look at the Veneer spectra on the next slide, we can see that we can accomplish that first goal of being able to grade the different berries. The green spectra that you see is the mean spectra of berries that were qualified as good by the grower. The orange line that you see is the mean spectra of the berries that were classified as bad by the grower. Again, based off of defects, regions of bruising, or water damage. We can see that there's definitely a difference in the spectra in the visible range here. And we can see on the classified images to the right that the first image are berries that were classified as good, and the majority of those have been colored green appropriately. And the vast majority of the berries that were bad are classified and colored orange as appropriately. On the next slide, however, when we look at the near spectra, we see that there's differences are a lot more subtle. And if we see that the classification model that we made based off of the near spectra, the majority of good berries are being classified as good, but when it comes to the bad berries, it's a mixed bag. If we wanted to be able to solve the problem of sorting between these berries, we definitely want to go with the Veneer, but that's not the only problem we wanted to solve. On the next slide, we can see the confusion matrices for that previous study, but then again on the next slide, we can see the regression models that we used for our Brix estimation. What we're doing here within the perClass Mira software is associating spectra of an object, a berry, and correlating it to its particular Brix value that we measured, we ground truthed in the lab. On the left-hand side, you will see the regression model that's made from the different Veneer images. And while it looks good, it has a R-squared value of 0.896. It's not as good as the near model that we're able to make with an R-squared value of 0.991. So we see that different spectral ranges, again, provide different information and can be leveraged to do different things. On the next slide, we can envision how a multi-scan package might be able to assist us when it comes to grading fruit, in this case, blueberries. We want to be able to first identify defects and grade the berries on good quality or poor quality. We'd want to use the Veneer range. We want to be able to estimate the Brix value of each of these blueberries that we're imaging. We'd want to use the near range. Historically, this means we'd have to have two separate setups with two separate sensors. But with multi-scan packages, we take the incoming berries, we image them simultaneously with the Veneer and near, and the output that we get will be a measurement of the quality of the berries and an estimation of their Brix values as well. But that's just one case study. We're not just limited to that. We can consider textile sortings as another case study where multi-scan can be extremely valuable for us to leverage. We want to be able to recycle textiles. We're going to have to be able to sort them by their color and pattern, as well as by their composition. Colors and patterns could be red, green, brown, etc. And the composition can range from acrylic, cotton, nylon, or a blend of all the different types of fabrics we can think of. We're going to image these different fabric swatches that we obtained on a Veneer near dual acquisition package, and once again, utilize perClass Mira software to analyze these images. On the next slide, we see the different mean spectras of all the different colors of the fabric that we imaged. And we can imagine that it's going to be pretty easy for us to be able to sort by color utilizing a Veneer sensor. On the next slide, we see an example of just that. The top left, you can see an image of green polyester fabric, and in the bottom left, you can see their green acrylic fabric. Both of them have been classified in the right-hand image as being green fabric. And we can see from the different classes that we had on the left-hand side that the green spectra can be correlated to both of them. But what about their composition? Well, on the next slide, if we look at the different spectra for different types of green fabrics composition, acrylic, nylon, polyester, or even a blend of some of these different fabric types, there are differences in each of these spectra. So once again, we can go to perClass Mira and utilize their different spectras to be able to create a classification model. On the next slide, you can see on the far left an image of nylon fabric. The top left, green nylon fabric, and the bottom left, brown nylon fabric. These are both the images from the visible range, which is why we see our color. The middle images that you see are from the near infrared range, and we can see that they look awfully similar. The green nylon fabric above and the brown nylon fabric below both share similar spectral qualities in this near infrared range. perClass Mira is able to utilize that spectra and correctly categorize both of them as nylon fabric in the near range, utilizing the near classification model. So since we know that these different sensors can do for different things, what might this look like when we deploy it? Well, on the next slide, we can see if we wanted to deploy it, we would first want to utilize that visible range to sort the fabrics based off of color, and then downstream sort those different colors into the appropriate compositions. So with perClass Mira Software and TCP/IP connections, we don't just have to rely on a stage, we can also do this inline. We can imagine this where we'd have incoming unsorted fabrics that are first sorted by their color using a V-near sensor, and then composition sorting would be done downstream by a near sensor. Once again, multi-scan offerings allow us to solve multiple problems utilizing the same connections and the same stream. So these different multiple modes of deployment can either be a lab-based solution, like the one that's in between myself and Will right now, where we can utilize a near V-near setup, like we did for these two case studies, or a SWIR V-near setup, such as the SWIR 384 MVC V-near setup we have on the stage right here. Just to give you a visualization to imagine what those inline solutions might look like, on the right-hand side, you can see that there are two MVC V-near sensors that are attached to the crossbar on the top left there. And then you also have an MVC near sensor that is attached on the right-hand side there. All three of these sensors are collecting data simultaneously via one master instance of perClass Mira and are triggered once they detect an object of interest coming down the line. So we can utilize, again, those multi-scan offerings in line as well. So just to summarize what we've seen so far, multi-scan packages are well integrated. These work seamlessly together and they allow us to collect more data for a wider variety of applications. And we can even solve more problems within the same application. Multi-scan offerings are not just limited to two sensors. In the image you just saw, we're able to collect 3 or more via TCP/IP connection. Multi-scan packages can be utilized in the lab, at line, or inline, and it helps us save time and money, us to be able to use for data collection. Instead, now can be used for model development, testing, deployment, and capturing the full range of spectral information and take advantage of all that hyperspectral imaging has to offer. Thanks for listening to these two case studies, and hopefully now you're a little bit more convinced when it comes to why multi-scan packages are so powerful and why you're going to want to be able to take advantage of them. Mikhael is just going to finish off by talking about some other applications that you can imagine multi-scan might be useful for.
Yeah, thank you, George. And again, thank you all for attending this webinar. I hope you're enjoying and learning, about the different multi-scan packages that we have. So today we talked about 2 examples related to blueberries and textiles, but our technology and our products can be used for a lot more. They could be used in different industries, including food, plastics, you name it. And here's a list. For example, we can use our product to detect foreign objects in herbs and spices. We can detect plastics, packaging, and cheese, so on and so forth. We can also use our products to detect and measure histamine levels in fish. We encourage you guys to contact us after this webinar and talk to us about your unique application. It could be something that we've done in the past, or it could be something that we would ask you to send us some samples to work with you on. Next slide, please. Also coming up next month, right before the 4th of July, we will be having another webinar on plastics recycling. And this will be another exciting webinar. We'll talk about the uses of hyperspectral imaging for plastic sorting and plastics recycling. We will be joined by our colleague from InnoSpec, Dr. Inga Niedermeyer, to talk to us in more details about the uses of hyperspectral in plastics, since InnoSpec has thousands of installs worldwide, mainly in the plastics industry. Next slide, please. And now I would like to pass it back to Marissa for Q&A.
Thanks, Mikhael. So again, just on the screen, you can see how to ask questions in your GoToWebinar control panel on your PC or phone. And we'll get started. So the first question is, thank you for the informative presentation. I would like to know if this system could be used to study cultural heritage objects. If yes, could you give a few examples?
I can answer that one. Of course, yes, hyperspectral imaging can and has been used to explore cultural heritage objects. The one that comes to my mind right away is that a Headwall system was used to scan Rembrandt's Night's Watch out of the Rijksmuseum in Amsterdam. Granted, that was a custom setup because if you know anything about the Night's Watch, it won't quite fit on this stage. But again, smaller objects could be scanned on this stage or other similar. Headwall has a larger scanning stage offering as well that could be used for larger objects too. And so, of course, you can use it to scan cultural heritage objects. I have taken some scans that I think are pretty neat where we scan a painting and then easily pull out the underdrawing from that painting. And so again, that's just a brief example. And the SWIR sensor can be used to learn more information about the paints and pigments that were used in some historical artifacts that might uncover information that wasn't known about how certain colors were made when these artifacts were made.
Okay. Are the dual sensor capabilities only for lab or inline capacities at this time, or are there UAV applications for the dual sensors?
So I can answer that one as well. Headwall has had a product called the co-aligned Veneer SWIR for many years. That is a well-established product. And that's available through my remote sensing colleagues. And again, if you contact Headwall about that, they'd be very happy to tell you about that. However, that package is slightly different than this dual scanning package here. That, again, we are promoting a dual scan package that is designed for laboratory use and inline use. And of course, you can use one of these packages to collect information in the lab that could be used to build ground truth models in order to be applied to remote sensing data as well. For more information about that, again, please contact Headwall Photonics and we'll be happy to talk to you more about your particular application.
Okay. If I determine that more than one sensor is needed over my product inspection line, how would those be deployed? Are they the same sensors as on the scanning kit? Do they have to be mounted together?
Again, I can take this one. So yes, they can be the same sensors as on the scanning kit. You could, of course, you could also keep your scanning kit intact and purchase other sensors to deploy over your line. So the scanning kit can remain for development, and then other sensors can be used for deployment. So either way works. And no, you do not need to do all the deployment in one location. The deployments can be physically separated from one another, can use different computers. One of the main utilities of this multi-scan package is for an investigative project where you are developing a model. It allows you to scan the same sample and create two different data sets with the same naming structure at the same time to rapidly develop models from two different sensors. And so again, that's the one of the big utilities of this. And then those two models can be deployed either at the same location in your line, or as we used in the textile example, you can sort for color or material in one part and the other one in another part later on down the line.
Okay. Can I pay you to conduct some scans to know which sensor is best for my use? Can I send you some samples? Is there a cost?
I guess I can answer the first part of that question. Can you send us samples for us to look at? Yes. Is there a cost? That's best answered by Mikhael Jobran, our sales manager for MV here in Americas.
Yeah. So that's a great question, actually. And as I mentioned earlier, we want you to send us samples. And even though we have had a lot of experience with the different companies that we have with multiple different applications, but every now and then we do run into applications that we haven't worked on in the past. And the best way to decide what camera is best fit for that application is for you to send us some samples, which for basic feasibility study, we normally do it at no extra charge to you. But if we are planning on doing an extensive study, then yeah, we have different support packages that we can offer you. And you could contact us after this webinar to learn more about that.
Are the lenses chosen to give me the same field of view?
Yeah, so the lenses that you see up here on the SWIR 384 and the MVC Veneer, the SWIR 384 has a 25mm lens, while the MVC Veneer has a 16mm focal lens, and they'll both achieve approximately the same field of view, but they won't be exactly co-aligned or looking at the same. When it comes to deployment inline, of course, we're going to make sure we we make sure we select the appropriate lens for your application, for your line, your belt width, the illumination, et cetera, et cetera.
Yeah, and I would add, actually, I would encourage everyone to go on our website and check out our field of view calculator. I think that's readily available for all of you guys to go and look at the different lens options that we have.
Okay, if I have one of your scanning kits and I change the camera, do I also need to change the lights?
I can cover this one. So if you're using our scanning kit specifically, as the question stated, no, you do not need to change the light, because our scanning kits come with halogen lights that will provide approximately a black body-like illumination that'll cover 400 nanometers to 2500 nanometers. Just to be careful, sometimes we do deploy solutions with LED illumination that is tailored to a specific spectral range. And so if you have a solution that is using a tailored LED illumination for the Veneer part of the spectrum and you want to move to near, then yes, you would need to update your illumination source.
Okay. If I buy a kit and then decide to add another camera, how do I do that?
Well, that's the easy part of all this. As you can see on the image on your screen to the right, the MVC Veneer attaches to the MVC near sensor just by a simple bracket and a few screws. And the SWIR system for the SWIR 384, the SWIR 640 with the MVC Veneer attaches by a unique bracket for the perClass Mira stage. So if you have a MVC near and you'd like to add on a Veneer, it's simple as adding on a bracket. But if you have a SWIR or a Veneer and you'd like to combine those together, another bracket that's separate for the perClass stage would need to be purchased. But simple additions for all those combinations.
Okay. Are any InnoSpec sensors available in these packages?
I will take that. So as of today, we do not have InnoSpec sensors available for these multi-scan packages, but of course there is a plan to tightly integrate the InnoSpec product line with the Headwall product line. So if you have not already subscribed to our newsletter, please do, and that will be the fastest way for you to know when those new products are released.
Do I save any money by buying a multi-scan package over individual sensors?
Yeah, I can answer that question. That's actually a great question, and the short answer is yes. So when you buy our dual scan or multi-scan package, you're basically buying, one stage, one lighting, one software with multiple cameras, and the answer is yes. And we encourage you to buy our multi-scan packages.
Okay. I got an email about the SWIR 384 promotion. Could you tell me more?
Yeah, that's another great question, and we do have a run-in promotion that's ongoing now. As a matter of fact, the package that's displayed on the camera along with George and Will is the package that we have a promotion on, which includes our MVC Veneer camera and SWIR 384 camera, along with the rest of the stage lighting software. I do have to mention that this promotion is on a first come, first serve basis due to limited stock. So if you're interested, you might want to consider acting now.
Will you hope to add the UV vis spectral range to the multi-scan setup?
I'll take that one. So that also prompts another sort of exciting teaser. So again, please subscribe to our newsletter and you'll get all of these announcements when they drop right away. We are currently developing a full UV scan package. So in short, it won't just be an add-on to the perClass Mira Stage because the UV introduces other experimental challenges that we're all taking care of for you when you buy the full UV package from Headwall. That will include a UV illumination source. It will have a full enclosure to protect you from the UV illumination is more dangerous for humans than just your standard halogen bulbs. And so that will be a new unique scanning system that will be available later this summer. So again, if you're interested in the UV package, please stay tuned and it will be available soon.
Okay, thank you to everybody who submitted questions for our Q&A.
Yeah, and again, thank you. And we, as I mentioned earlier, we encourage everyone on this webinar or whoever sees or watches this webinar later on to contact us, talk to us. We're interested in talking to our customers, learning more about your challenges, how we can help you. You could either send us samples, or we're also happy to come out and see you, bring our MV scan package, run some samples with you. You could email us directly or email our information at headwallphotonics.com. We also want to remind you that our website is a great resource. If you go on our website, you could have a chance to watch all of our recorded webinars, learn more about the different products, go over the different applications that we work on, not only for machine vision, but also for remote sensing and our other business units. Next slide, please. Yeah, and again, I want to thank everybody for attending today's webinar. Special thanks to our machine vision team here in the Americas. Special thanks to Will and George and our marketing team as well. And we look forward to seeing you again next month.
Thanks, everybody.
Thank you very much.
Thank you.